Welcome to the database management unit of the degree program. Today we are going to explore this topic called relational algebra. I am not sure whether you all are familiar with this title, relational algebra. So we are going to see what it is today. Now if you consider a data model, it must include a set of operations to manipulate a database. So relational algebra basically presents the basic set of operations for the relational model. So as the first statement says, relational algebra is a formal language associated with the relational model. So we see why relational algebra is so important. So as I mentioned, it is the formal foundation for relational model operations. That is the first reason. And the second reason is it is used as a basis for implementing and optimizing queries in relational database management system. And as the third reason, some of its concepts are incorporated into the SQL query language. So because of these reasons, relational algebra is considered as a very important module. Now informally, relational algebra is a high level procedural language. So what does it mean by procedural language? That means it uses a step-by-step approach to create a relation. And now basically this enables a user to perform a retrieval request. So what are the features of this relational algebra operations? Now relational algebra operations work on one or more relations. Now it can be applied on only one relation, or it can be applied on more than one relation. And that will define, after applying the relational algebra on a relation or number of relations, that will define another relation. But you have to keep in mind it does not change the original relations. And secondly, both operands and results are relations. So output from one operation can become input to another operations, like other mathematical operations. When you apply relational algebra operation on a relation, the output will again be a relation. So this feature allows expressions to be nested, as I said before, just as in arithmetic operations. So this property is called the closure property. And if we are going to categorize these relational algebra operations, we can categorize it in number of different ways. There are 5 basic operations in relational algebra. They are selection, projection, Cartesian product, union, and set difference. And I hope that you all are still not familiar. You may not be familiar with these operations, but we will look into this more detail later. And so these perform most of the data retrieval operations needed. So I said that there are 5 basic operations, and again there are other operations that can be defined in terms of these 5 basic operations. They are join, intersection, and division. So this is one way of categorizing relational algebra, that is basic operations and the operations that can be defined in terms of basic operations. And there is another categorization, that is set operations, such as union, intersection, set difference, and Cartesian product. And then others are like selection, projection, and join operations have been developed specifically for relational database model. And Then another categorization which would be unary operations and binary operations. Unary operations are performed on one relation such as select and project, and binary operations are performed on more than one relation such as join. So, this is how we visualize. Before we go into details of these relational algebra operations, if we visualize these operations, we can see how they look like. Now, selection, projection, Cartesian product, union, intersection and set difference. As I said before, except intersection, all the others are 5 basic relational algebra operations. So, if I explain this selection operation first, this is also known as restriction operation. This is the symbol here is sigma. The symbol is sigma, and then you define the condition and then the relation that you are going to apply this selection or restriction. So, if I am to explain what this is, now this selection, as I explained before, works on a single relation R, and it defines a relation that contains only the rows of R that satisfy a given condition. Condition is given here as predicate, and so this can be visualized as producing a horizontal subset of a table. A horizontal subset table. Now, if I am going to illustrate this with an example, here the example is to retrieve all employees working for department number 7. Now, I have given a very simple relation here for simplicity, and I have selected, I want to see only the employees, those who are working for department number 7. So, here as you can see, the sigma symbol is there, and the condition is department number equals 7, because we want to see the employees, those who are working for department number 7, and it is applied on the relation employee. So, as I showed you before, the syntax I showed you before. So, this is order. So, this will create another relation called sales employee. As you can see, it has selected only the rows satisfied the condition, that is department number 7. So, all the other rows have been discarded from this new relation, but the origin is intact. What we see is this new relation from the original relation. And if you consider the number of attributes here, it is similar to the original the attributes in the original relation. Now, all the employee number, employee name and department number attributes are there. Now, if we consider another property of this selection relational algebra operation, selection algebra operation is commutative. If I am going to illustrate that, now you can apply number of conditions on the relation, and now if you apply condition 1 after condition 2, it is similar in applying condition 2 after condition 1. For example, if you had another attribute here, let us say salary, and if you wanted to let us say if you wanted to display or to retrieve the employees, those who are working for department number 7 and also those who are getting more than 20,000 rupees, then there are two conditions here. So, first you can select the employees, those who have those who are getting more than 20,000, and then from those rows you can select the employees, those who are working for department number 7. or else you can select the employees, those who are working for department number 7, and then you can filter those who are getting more than 20,000 rupees. So, whichever the way you use, you will get the same result, which means the selection relational algebra operation is commutative. Now, let us explore another relational algebra operation, that is projection, and here the symbol is pi, and then you have to give the attributes that you want to select, and then it is applied on a relation. And as I explained before, these are all unary relational algebra operations. So, this works on a single relation R and defines a relation that contains a vertical subset of R, and it extracts the values of attributes specified, and it also eliminates duplicates. So, this projection can be considered as producing a vertical subset of a table. Now, if I am going to illustrate it through an example, now again there is this employee table, and now this time you want to see only the employee number and employee name. So, you define the projection operation with pi, and then you define the list of attributes that you want to retrieve, employee number and employee name, on the relation employee. So, it will produce another relation called employee names, and as you can see only two attributes. So, the degree of this relation, that is the number of attributes in this relation, is equal to the number of attributes in this attribute list. That is, the degree is equal to the number of attributes in this attribute list. The next one is how to apply sequence of operations. Now, we may want to apply several relational algebra operations one after the other. Now, for example, let us consider that you want to retrieve the first name, last name and salary of all employees who work in department number 5. So, in doing this, we can obviously and of course, we can write a single relational algebra operation. So, in doing that, we have to nest the operations. For example, we select the employees, those who are working for department number 5 first, that is the selection operation, and the condition is department number 5, department number equals 5, and from that we select or we project the first name, last name and salary, because those are the attributes that we want to retrieve. Sometimes you may think that whether you can do the projection first and then the selection after that. Now, let us see, if you do the projection first, you will project first name, last name, salary from the employee, and then what you have to do is to select the employees working from that. You have to select the employees working for department number 5. But if you have done projection first, that is not feasible, because the department you have omitted department number 5. So, in doing this, in performing this retrieval operation, you have to select the employees working for department number 5 first, and then from that output or from that relation you select or you project the attributes that you want to retrieve. Now, another way of, now this is a nested, this is how you write this using by nesting operations. Now, this is another way of writing the same thing. Now, you perform one operation at a time, and then you show the intermediate relations. Now here first you have selected the employees working for department number 5, and then the intermediate relation is called department number 5 employees, and then you perform the projection operation on department number 5 employees to get the eventual result. Now let us consider the union operation. Now as I explained before, this is a binary operation. Now union of two relations R and S. Now R is one relation, S is another relation. So that will define a relation that contains all the tuples of R or S or both R and S. But here duplicate tuples will be eliminated. So to perform R union S, R and S must be union compatible. So I am not sure whether you all are familiar with this word union compatibility. Now union compatibility means both R and S, the degrees of R and S must be the same. That is, if R has got 5 attributes or 5 columns, S should also have 5 attributes of 5 columns. So their degrees should be the same, and each pair of attributes should be from the same domain. Each corresponding attribute, for example, let us say the AI attribute of R and let us say BI attribute of S are compatible, then they should have the same domain. And if R and S have I and J tuples respectively, now when you obtain the union, you concatenate these rows together into one relation. So the maximum number of rows in the result would be I plus J, because if there are duplicate tuples, they will be eliminated. So the maximum number of rows would be I plus J. So if we are going to illustrate this with using an example. Now this is let us say one relation student and another relation called instructor, and now we are going to apply union operation on these two relations. Now first they have to be, as I mentioned, they have to be union compatible. To see whether they are union compatible, you can see whether the degrees are the same. Now this has got first name and last name, 2 attributes. This one also has got first name and last name, although it uses a different name for that, and then so their degrees are the same and their domain should be the same. Now as we can see, first name is a set of characters or a string, and here also first name is again a set of characters or a string, and it is the same with the last name. So they are union compatible because they are of the same degree and their domains are they have the same domain. So when you perform this union operation, student union instructor, it will give you it will concatenate the rows of a student with rows from instructor. But as you can see, there are common rows like Kapila Dias, Nimal Pereira. Here also you can see Nimal Pereira and Kapila Dias appear, but in this relation, of the relation that you get after applying union operation, you can see these two names, Kapila Dias and Nimal Pereira, appear only once. Now we can illustrate this again through another example. Retrieve the employee number of all employees who either work at department 5 or directly supervise an employee who works in department number 5. So this is a situation where you will have to apply union operation. Now first you have to get the employee numbers of employees who are working at department number 5. So if we look at the answer here, you can see that we have filtered or we have selected through the selection operation the employees, those who are working for department number 5. So these are this department number 5 employees will give that result, and then from that we get the employee numbers by applying projection operation, and then that is the first part, and then we want to have we want to filter another set of rows which satisfy the condition which says they should be the supervisors of the employees, those who are working at the department number 5. To get that, again we use a department number 5 employee relation, and then we project the supervisor number column or the attribute, and then you can see that this has been renamed. This is called rename operation because supervisor number again would be the employee number. Supervisor number in turn would be an employee number. So instead of showing it as supervisor number, we rename it to employee number, and this is this relation is result 2, and what we are doing here is to get the eventual output or to get the eventual result, we take the union of result 1 and result 2, that is concatenate the rows of result 1 with the rows of result 2 to produce the eventual result relation. Now let's have a look at the set difference. Now the notation is R minus S. So this defines a relation consisting of the tuples that are in relation R but not in relation S. So again, to apply this set difference operation on these two relations, they must be union compatible. Now you all are familiar with what union compatibility is. Their degrees should be the same, and each corresponding attribute should be from the same domain. Now if we illustrate it through the same example, there is this student relation and the instructor relation, and this is the output you get, this is the result you get through applying student minus instructor. The difference between student and instructor will give you this result, and the difference between instructor and student will give you this results. So you can see that the difference between student and instructor would not be the same as the difference between instructor and the student. Then the intersection operation. Intersection defines a relation consisting of the set of all tuples that are in both R and S. So again, to apply this operation on R and S, they must be union compatible. Now this can again be expressed using basic operation set difference. So R intersection S is equal to R minus the difference between R and R minus S. So now I am going to illustrate the same the intersection operation using the same example, student and instructor. So if we take the intersection of student and instructor, this would be the result you get. That means you will get the students, basically you will get the students, those who are instructors as well. So, as you can see, the two names Kapiladias and Nimal Pereira appear in both relations. So, this is what you get after applying the intersection operation. So, if we have a look at the features of these operations, union, intersection and set difference. Now, both union and intersection are commutative, that is R union S is equal to S union R. It does not make any difference. You can take R union S or you can take S union R, but you will get the same output. And R intersection S is equal to S intersection R. So, therefore, these operations are considered as commutative. Now, either operation can be applied to any number of relations. So, you can do R union to S union T, or else you can take R union S and then union that with T, and same way you can take R intersection S and then take the intersect that with T, or else you can take R intersection with S intersection T. But so that is with respect to union and intersection. But if we consider difference operation, that is not commutative. I hope you can remember that we took instructor and student relations to illustrate that, and we showed that the instructor, the difference between instructor and student is not equivalent to the difference between student and instructor. So, likewise, the difference between R and S is not equal to the difference between S and R. Then let us consider the Cartesian product. It defines a relation, that is the concatenation of every tuple of relation R with every tuple of relation S. So, eventually it will create a single table from two tables. Now, to illustrate this further, if R has n r number of rows and S has n s number of rows, then taking R Cartesian product S means the resultant relation will have n r into n s number of rows. Again, if we are going to use an example to illustrate this, there is this employee relation and the department relation, and employee has got 3 rows and department has got 2 rows, and if we are going to get the Cartesian product of employee and department, so this is the output after applying Cartesian product to employee and department. And as you can see, this has got 3 rows and this has got 2 rows. So, 3 into 2 would be 6. So, the final relation has got as you can see 6 rows. So, it will get the it will create the combination of all the combinations of rows. It will include all the combinations of rows. So, there is this important operation called join, and we use it so much in forming SQL queries. Now, join is considered as a derivative of Cartesian product. So, this join operation can be stated in terms of Cartesian product followed by a select operation, followed by selection. So, it is like this is equivalent to performing a selection using join predicate as a selection formula over Cartesian product of the 2 operand relations. So, the difference between join and Cartesian would be, now in Cartesian, as I explained before, all the combinations of rows will be included in the resultant relation, but if you consider join, only the combination of rows that will satisfy the given condition will appear in the resultant relation. So the problem here is that this is a difficult operation to implement efficiently in the relational database management systems, and that's why sometimes these relational database management systems have performance problems. Now if we are going to illustrate the general form of join operation on two relations, this is the relation R with A1 to AN number of attributes, and this is the relation S with B1 to Bm attributes, and then we can join R and S, this is the symbol for that, and with the join condition. So the general join condition is of the form condition and condition and condition, which means that you can give number of conditions combining them with let us say AND operation. Now so in generally we can say that this is of the form AI theta Bj. So AI is an attribute of one relation, let us say R, and Bj is an attribute of the other relation, that is S, and to have this AI theta Bj condition, AI and Bj should be from the same domain, and theta could be one of these comparison operators, that is equal, less than or equal, greater than or equal, or not equal. A join operation with such a general join condition is called theta join. So when we use this join operation, we most commonly use the equal operator, that is the comparison only, and this is known as equijoin. So in this equijoin, we always have one or more pairs of attributes that have identical values in every tuple. So that is the drawback of equijoin. So to illustrate that, you can see that there is manager ID and employee ID, because this would have been a situation where department relation has been joined with let us say employee relation. So you can see manager, so you can join it with the common attribute manager ID. So manager ID and employee ID, manager ID is in turn an employee ID. So after this equijoin, you can see manager ID and employee ID, they both are appearing, but they have the same values. So there is a duplication, or this is actually redundant. So a new operation called natural join has been defined, and that is denoted by the star symbol to get rid of this duplicate column. So this says the same thing. The natural join denoted by star is created to get rid of the second attribute. And there is another kind of join operation called outer join. This has been defined to display rows in the result that do not have matching values in the join column. Now the symbol is this, a bit different to the symbol is a bit different to the join operation. Now if I am to illustrate that with an example, now if we want to retrieve all employee names and the departments that they manage, if they happen to manage a department. So you know that only some of the employees can become managers to manage departments. So, which means that some of the employees can exist. If we join these, most of the employees may not have a corresponding department. So, in doing that, we use this outer join to join employee and department with the manager ID, and if the employee is here, the feature is that if the employees do not manage any department, that can be indicated with a null value. So, you get this temp relation, and then you project the first name, last name and department name from the temp relation. Again, there is another relational algebra operation called division operation. This will also be applied on two relations. Here they have been defined as R and S. R has got two attributes here, and S has got only one attribute called A, and R has got A and B. So, I use this to illustrate that if we are going to apply this operation on these two relations, so the attributes in S should be a subset of the attributes in R. So, then when you now R has got two attributes, and here S has got one attribute. So, after applying the division operation, you can see that the result you have got as a the relation you have got as a result has got only one attribute. So, if we call this y, the number of attributes in this relation is y is equal to the number of attributes here minus the number of attributes here in this relation. Now, I am going to illustrate an example of division operation. Now, this is the example that I selected. Now, what we want to do here is to retrieve the names of employees who work on all projects that Sunil Silva works on. So, here the not only on one or two projects that Sunil Silva works on, we want to get the names of employees who work on all projects that this person called Sunil Silva works on. For example, if Sunil Silva is working on 5 projects, we want these employees to work on all those 5 projects. So, in doing that, what we have to do first is to select the record of Sunil Silva from employee. Select the row Sunil Silva's row from employee, and the intermediate relation would be Sunil. So, this will have this relation Sunil will have the details of Sunil Silva, and then we combine we join this relation called Sunil with works on relation with the employee ID to get the project numbers of the projects that this person Sunil Silva is working on, and the relation would be Sunil's project numbers. So, this relation will have only one attribute, that is a project number, and then we have works on relation, and in works on relation from works on relation we project employee ID and project number, and this is this will be in a relation called temp. And now what we are going to do here is to apply the division operation on temp and Sunil's project numbers. So, we divide temp from Sunil project numbers relation, and to do that you can see temp has got two attributes, employee ID and project number, and Sunil has got Sunil's project numbers relation has got one attribute, that is project number. So, project number attribute is a subset of the attributes in temp relation, that is employee ID and project number, and then the output would be in a relation called result 1. So, this result 1 will have the names, then this result what we want is the names of the employees. So, this result 1 will have only the employee IDs, because what we get is the difference between the number of attributes in these two relations. This has got two attributes, temp, and Sunil project numbers has got one attribute. So, this result will have only one attribute, that is the employee ID, and then we join that with employee to get the names of the employees, and this eventual result relation will have the names of the employees who work on all the projects that Sunil Silva is working on. Then I am going to do some examples using this company database schema. In company database schema, we have a number of relations: employee, department, works on, project, dependent, and department locations. Now, employee has got number of attributes to describe the employee with the first name, middle name, last name, birth date, and most significantly employee ID, address, gender, salary, supervisor number, and the department number that employee is working at. And the department relation has got department number, department name, manager ID, manager date. And works on is a relation that combines employee ID and the project numbers and the number of hours that each employee is working on each project. And project relation has got project number, project name, project location, and the department number, because departments are controlling or managing the projects, and there are dependents for the employees. So, that relation is here with the dependent name, gender, birth date, and relationship to the employee ID along with the employee ID. And the other relation is department location with the attributes department number and location. So, we use this company database schema to illustrate these examples. So, in the first example, we are going to retrieve the name and address of all employees who work for the research department. So, now when we read this retrieval operation, now it should come to your mind as to how to perform this query using relational algebra operations. Now, the answer would be this, and now you see that here we have used the department relation to filter the details relevant to the research department. So, we filter or we perform the selection operation on the department with the condition department number equals research. So, then we get the research department details, and then we combine that with employee using the department number, because we know that department number appears as a foreign key in employee relation. So, we use a join operation here, and we get the employees working for the research department, and but we only want to see their first name, last name, and the address. So, because of that we perform the projection operation on the research employees to get the final output. In the next example, what we want to retrieve is, we want to see for every project located in Colombo, list the project number, the controlling department number, and the department manager's last name, address, and birthday. So, here we want to get the, first we want to get the projects located in Colombo. So, in doing that, we perform the selection operation on a project to select the projects located in Colombo. So, the condition is sigma condition is project location is equal to Colombo, and we get Colombo projects, and then we want to see the controlling departments. So, for that we join Colombo projects with the department relation using department number. And the other thing we want to see is not only the controlling department number, the department manager's last name, address, and birthday. So, we combine this control department relation with the employee using manager ID, and we get the managers in that department, manager in each department with respect to the project located in Colombo, and then from that we project number, department number, last name, address, and birthday to get the final output. Now, the next example, through the next example, we are going to retrieve the names of employees who work on all the projects controlled by department number 5. The employees who work on all the projects controlled by department number 5. So, when you read this, I think you should be able to figure out the relational algebra operation that you are going to use, because of this word who work on all the projects controlled by department number 5. So, let us see the answer, and I am going to illustrate how we got the answer. Now, here we want to find the projects controlled by department number 5 first. So, we apply the selection operation, department number equals 5 on project, and then from that we get only the, we project only the project number, and that is department number 5 projects, and from works on we get employee ID and project number, and what we are going to do here is we perform division on these two relations, employee project and department 5 projects. So, we basically divide employee project relation by department 5 project, and when we do that we get the employee IDs, employee IDs of the employees who work on all the projects controlled by department number 5. But what we want is the names, we want the names. So, we combine this relation with the employee relation to get the names, and then since because we only want to see the names, we use the projection operation to filter the last name and the first name, and this result relation will give us the required output. The next example would be to find out a list of project numbers for projects that involve an employee whose last name is Pereira, either as a worker or as a manager of the department that controls the project. So, here you have to find out two things. First thing is, you have to list the project numbers for projects that involve an employee whose last name is Pereira as a worker, and the other would be this last name is Pereira as a manager of the department that controls the project. So, in doing that, first we get the employees whose last name is Pereira. To find that out, we perform the selection operation on employee with the condition last name is equals Pereira, and from that we select the employee ID, and that would be in a relation called intermediate relation called Pereira, and then we join that with works on relation to get the project numbers that Pereira is working. This employees with the last name Pereira are working on. We join this with works on, and then from that we project only the project numbers, and then we combine employee and department using employee ID and the manager ID from the department, and from that we project last name and the department number to find out the managers, and then from that we get the last name equals we apply last name equals Pereira condition to select the managers with the last name equals Pereira, and from that we get the we filter the department number. So, in the first relation that we did, we got the projects that Pereira is working as a worker, and here we got the from this relation we got the departments that Pereira is working as a manager, and then we combine the relation that where Pereira is working as a manager with the projects to find out the projects that are controlled by this particular department, and from that we select the we project the project number. So, then what we do is, now we have got we selected this one first, that is the projects that Pereira is working as a worker, and here are the projects that are controlled by the departments where Pereira is working as a manager, and we want the union of this. So, we take the union of Pereira worker project and Pereira manage project, and this result relation will give you the required output. So, the other one, the other query is to retrieve the name of employees who have no dependents. So, then again when you read this query, I think the applicable relational algebra operation should come to your mind. Now, here we get the employees, we get the employee ID from the employees, that is we project it. So, we get all the employee IDs of the employees, and then from the dependent relation also we get the, we filter or we project the employee IDs. So, here in this relation we get employees with dependents, but this relation has got only the employee IDs, and then you know that to get the set difference they have to be union compatible. Their degrees should be same and they should be of the same domain. So, as you can see, this has got employee ID, all employees relation has got only employee ID attribute, and employees with departments has also got employee ID attribute. So, their degrees are the same. So, you can apply the set difference operation. So, you take the difference between all employees minus employees with departments, because you have to retrieve the name of employees who have no dependents. So, when you take the difference, you will end up with a relation that has got only employee IDs, and these the employees corresponding to these employee IDs do not have a dependent. So, but we want to display the names. So, we combine this employee ID, this employees without dependence relation with the employee. We join it with the employee through the employee ID attribute and get or project the last name and first name to get the final output. So, in the next example, we are going to list the names of managers who have at least one dependent, not the employees, they should be managers. So, we are going to list the names of managers who have at least one dependent. Now, here to get the managers, first we have to go through the relation called department, because department relation is the one that has got manager ID. So, we filter or we project manager ID from the department relation, and here that has been renamed to employee ID, because manager ID, manager number is in turn an employee ID. And then from the dependent also we have got the employee ID like the way we did before, and these are the employees with dependents. And to retrieve the names of the managers, those who have got dependents, we have to get the intersection of these two relations, that is managers intersection employees with dependents. So, this will give you a relation with employee IDs, and this relation has got the employee IDs of the managers with dependents, but this is not really what we want. We want the names. So, to get the names, you join this managers with dependents relation with the employee relation, and from that you project the last name and the first name, and this result relation will give you the names of the managers that has got those who have got dependents. So, I think I illustrated, I explained the relational algebra operations, and then I explained it through examples. So, you have to do more queries and questions to practice this, and thank you so much, and we will meet again with another topic.